This show is supported by you, the listener. Stick around to Left Foot News to hear a tiny bit about that. This is Cup of Go for March 20, 2026. Stay up to date with the important happenings in the Go community about 20 minutes per week. I'm Jonathan Hall.
And I'm Shai Nechmad. It's going to be tough to stick to the 20 minutes frame this week. We have a lot to talk about. But first, how are you doing, Jonathan? What's up with you?
I'm good.
How's the weather where you are?
Oh, yeah, it's great. I've got the window open. I can hear the birds singing outside. How are things there?
It's hot. There's a heat wave in California. But last night, evening, I had a housewarming party, pizzas and wine in the backyard, very American style. Yeah. It was very nice. And I was like, man, I ate a lot of pizza. I better stay in good shape and eat healthy things today. Not me walking into the WeWork office and they're like, free donuts.
I want one.
But I held steadfast. I did not take their promise of carb and sugar. Yeah. Do you have any alternative sugar you can give me?
I think I could talk about some syntactic sugar if that would help satisfy your cravings. Let's take that. All right, so I'm going to try to explain this proposal that's been accepted, but it's kind of hard to do in a podcast format. I'll do my best. If I lose you, check the show notes for a link and you can read it yourself. So
I imagine 20% of the audience checked out. Oh, I'll wait until they get to the next item.
Yeah,
no, probably. Stay with us. We can do it. We can do it together.
So this is about generics. So I don't know if it'll affect you, Shai, since I don't think you're using generics much in Go. But for those of you who do use generics, imagine you have a type S that is a struct, and it has a field F that is a function type. Let's say func int. Okay. So a struct has a function type field.
That makes sense.
Now you have another type that's a generic type. Let's say G with type parameter T of any. And actually, this is a function, not a type. So function, it's a generic function. Function G takes a type parameter of T, which is any.
Okay.
Now, can you assign that function, that generic function, to the field of your struct? That's the question.
To me, it makes sense because the field of the struct, you said it's a function that gets an int, and the generic function takes any. So why won't I be able to do it?
So you should be able to assign that, assuming T is int, right? Since the struct is only func int, the struct field is only func int. As long as your generic function matches that signature int, you'd think you'd be able to assign it. Well, the answer is more nuanced than that. You can and you can't assign it. It depends on how you do it. So if you say you have a variable that is that struct type, let's say S, you could say s.f equals G, that generic function, and that's fine. It infers the type is int. It lets you assign it. All is well and good.
So so it can be assigned.
It can be.
Okay.
You can also assign it if you use a struct literal. So you say S equals, and then say big S for your struct type, curly brace, F colon G, square brace int. So you're specifically saying, I want to assign this generic function of type int. So those two...
Wait, and in the first initialization, I didn't have to specify the type.
You did not have to say the type. It was able to infer that.
Wait, so why can't the compiler, I guess, figure out... Isn't it the same thing?
It is the same thing, but right now, as of Go 126 and earlier, if you do S equals big S, curly brace, F colon G without specifying the type in that format, it doesn't work. So the proposal is to make that work because why not? It makes perfect sense. It just doesn't work now for historical reasons. This proposal has been accepted. You will be able to do that starting in Go 127. Was it worth it?
Does it matter? I can in all places where I use this assignment, can I just use one of the forms that work?
You could, but it's annoying. It's annoying to have to say specifically int when it can be inferred.
Yeah, of course.
So it's not adding new capabilities or making the language more powerful in any particular way. It's just a little bit of syntactic sugar, so you don't have to specify your type in certain very specific situations.
Well, you're right. This doesn't affect me because I don't write this sort of code very often. But I imagine being surprised by trying to assign it one way and it works and then another and it doesn't work. And it's nuanced enough that I think even Claude couldn't figure it out for me. It'll probably write some
Very likely.
hellish workaround instead. So I guess good on them for fixing it. And this is not a breaking change or anything, right? There's nobody who relies on the one of the forms not working.
Yeah, it's strictly additive. So there's no previously valid code that would be made invalid by this. Only the other way around.
All right. Well, you know what? All this generics, function type, inference, this is like complicated stuff. You know me, I'm just like writing super simple code, just like concatenating string with plus, and everything's working and everything's great. No comments there, right?
Yeah, nothing to say on that topic. No reason to string this along.
No reason to string this along is good.
All right.
Man, I know a really good string joke, but it only works in Hebrew.
Well, some of our listeners speak Hebrew. Go for it.
All right. איש אחד הולך ברחוב וגורר אחריו חוט. אז מישהו שואל אותו, לאן אתה הולך? הוא אומר, לבית מרקחת. אז הוא אומר, למה? הוא אומר, לקנות קרם לחוט. So, Go string concatenation performance optimization. So, I have to concatenate strings all the time. Unlike writing generic types and then assigning them to concrete struct types. I do it all the time. I am aware that plus is not the most efficient because sometimes I get a string, like someone tell me, oh, please use another function. But I actually don't know what's the best one. What's the best one?
Can I say it depends?
Nice. Can you give me like a rule of thumb?
A rule of thumb, the best is probably to use strings.builder. I almost never use strings.builder.
So why is it better? By the way, we should say that we're basing this discussion based on a blog post from Winterjung, which is actually, it's not super new. It looks like it's from last year. Yeah. So it might not even be like the most up to date.
I don't think anything about this has changed in that time frame, though.
Yeah, for sure. But something popped it up to my attention. I got it like through some link or whatever. And I just want to say the blog is pretty cool. Most of it is like in Korean, so it's hard for me to review. But looks like someone who's a very strong Go contributor, regardless, in Korea. Yeah. So, you know, I like seeing these sort of real personal blogs. So thanks, Winter, for sharing this blog post. So what's the best method?
Yeah. So first off, maybe explain why just concatenating strings with plus isn't ideal. The reason is because in Go, strings are immutable. You can't change a string, right? So if you say string equals string plus quote foo or whatever, you actually have to create a new copy of that string in memory, copy the old value with the new value to a new memory location, and the old memory location gets cleaned up by the garbage collector. If you're just doing that once or twice, generally not a big deal. But if you are doing something like, say, building an HTML output, line by line or something like that, or anything that you're doing this repeatedly, you're just creating tons of garbage for the garbage collector to clean up. So what's the alternative? Well, there are several. The blog post goes through using functions like fmt.sprintf or fmt.sprint, strings.join, bytes.buffer, and strings.builder. Strings.builder is the new kid on the block. It was introduced only in Go 1.10, 6-7 years ago. So it's not that new, but of these options, it's the newest.
8, right? If we're on 26 and
yeah,
this is 10,
it should be 8. Yeah, it should
16
be 8
divided by 2.
Yeah, is that how that works?
Well, it depends if you're rounding it up or down, I guess.
Ooh.
Oh, foreshadowing.
So basically, bytes.buffer and strings.builder, which sort of improves on that slightly, is the idea of allocate a bunch of memory first and add your strings to that single allocation rather than replace and delete every time. So that's why strings.builder is faster, because it sort of collects all your strings together, and then when you call, I don't even remember how you use it anymore, but you call the finalizer method, and it returns the string constructed in one swoop instead of as a whole bunch of intermediate steps. But the reason I don't use it very often is because I'm very rarely doing lots of string concatenation, and for short things, it's very cumbersome. It's It's several lines of code versus just foo plus bar.
Yeah, and Winder notes here that in fixed argument scenarios, so not like building, a very long HTML form or whatever, but just putting in 3 strings and putting a delimiter between them or whatever. Mm-hmm. You can imagine building a version string, right? So 1.0.0 seems like, according to his benchmarks, it's kind of the same. If you use plus, it's like perfectly adequate. But always strings.builder with the grow method or strings.join is the fastest and most memory efficient. And here's my question to you. Why doesn't GoFix replace all plus calls with strings builder if it's always faster? Or at least, I don't want to say always faster, but at least
never slower.
It's always one of the fastest, I guess is what I should say.
So I can think of a couple reasons why. One is technical, and that is that I believe GoFix requires a GoFix directive. Maybe that's not strictly true. Maybe it can detect certain patterns and fix them for you, but I'm not certain. So that would be one technical reason that I don't believe that it's possible. You'd have to go add GoFix directives to every one of your string concatenations to do that, at which point just fix it at the same time. Second, it's not strictly identical in all cases. So it could introduce breaking changes. The example I'm thinking of is where you take the address of a string. Guess you could do it with string builder. Mm-hmm. You take the address of the return value rather than the string itself. But it certainly would hurt readability in many common cases.
Yeah, you're just concatenating something for a log and then suddenly var builder, strings builder.
Yeah, and so it's not that concatenation is itself bad. Like maybe you're only using the string once, and so you just need to join foo and bar to use it. And in that case, using strings builder versus concatenation is probably exactly the same in terms of the operations. It's where you repeatedly add to a string and throw away the intermediate result that is a problem.
It's worth to note that I've ran profilers a few times, and very rarely have I opened it up and been like, oh, string concatenation. That's the actual slow part in my program. But still I was surprised.
Where I have seen the worst abuses of this is the types of programs that somebody might write in Perl or Ruby or Python, where they just don't care about performance anyway. They're, if you could just as well write your program in Python and it would perform adequately, then this is not your bottleneck. So you don't really need to care anyway.
Yeah, for sure. One, I think, unfortunately, final thing for our news section, even though our backlog is screaming, is a podcast. Wait, you put another podcast link here.
Don't listen to this podcast. We're really jealous about our listeners. No. We're not at all. This came up in our channel, our Slack channel.
Hashtag Cup-A-Go with hyphens, kebab case on the Gopher Slack.
That's right. Ashu pointed out that they had a discussion about the error interface over on the Fall Through podcast. What do you think about the error interface, Shai? Is it a good thing? Is it a bad thing? Mixed feelings?
I feel like it's very simple. It's as simple as it can possibly be. I love errors that, have the stack trace and a reason and a code. And then you go, like Postgres, you go to a page that's full of like error codes and their meaning. But keeping it very, very simple, it's just string, right? There's literally nothing else in that interface. I think it's very Go-y in nature.
Okay. And is that a good thing or it's a mix?
I think for me, it's good because you can always expand on it. You can always okay, my error is stringable, but also, I'll have the error code and the error type and the line where it happened and other tracing information. You can always add more. But I love things that are so simple you can't subtract anything. Okay. It definitely feels at times like, okay, this is a type error. This is just a redefinition of string that's called error, and let's all pretend that it's a special thing.
So it's a little different than a redefinition of string because, as you said, you can add other stuff to it, right? You can add stack traces or arbitrary other things. So it's actually more like a redefinition of any.
Ooh. Why? Is any stringable?
It's not. So that this is, or maybe more strictly, is more like a redefinition of the stringer, the FMT.stringer interface.
Yes, definitely.
Because you can, through what's often called interface smuggling, add other interfaces to it, like to include a stack trace or error codes, Postgres error codes, or
I will just say that definitely the when I think about an error, the main thing I want to do is read it so I can understand what happened and then fix it or ignore it or whatever.
Right.
As a person, like if an error wasn't handled gracefully or whatever in some spot in my program, I usually I just want to read it. I want to read it and like my log output to understand what happened. So very programmatically, to me, it makes sense that it's a redefinition of stringer and nothing else. When I'm writing error handling code in my software, that's where I want like the error codes and the like, what HTTP code did you get? Oh, you got a bad code, whatever. And then, handle based on that.
Right.
And that's specific to, it's always going to be specific to the type of error that I was able to predict had happened. So of course I don't want it to be part of the error interface. That's my take on it.
Yeah, I think you're aligned with the fall through guys. The problem is that it's when you're programming error handling, it's too unspecified. It's basically any at that point. For end users, a string is all you need. You want to send a string, and that's fine. The problem is those two consumers of the error have very different needs, and we've only accommodated one of those, the less interesting one, right? Which is not very Go-like when you consider that we have this we have strict types. One of the proverbs is any doesn't tell you anything, and error tells you almost nothing else. So the point of this podcast, or the section of the podcast, was that the error interface is a smell, and he makes the analogy: what if we had the same construct anywhere else in the language? Maybe instead of error, you had some construct that returns a value that just returns that has a function, is an interface that returns has a function called value on it that returns a string, and you use that for everything. Nobody would stand for that, right? We would just be like, that's ridiculous, that's stupid. I want to know the actual thing. I don't want to have to reparse this string every time I need a value from this interface. But that's essentially what we're doing with error. Now, we've kind of improved that in the sense that error wrapping has become standard. It was added to standard library in 1.13. So you can get at more underlying things, but then you're still at the essentially any interface where you have to do type assertions and big if blocks and so on. So I largely agree with the criticism of the error type in Go. I'm less convinced about their proposed solution, which is to return, to use the multi-return capabilities of Go functions to return a placeholder value for every error type your function might return. I can kind of see the argument. So let's say you have a function that could have two possible error types.
It can fail on file not found or like connection failure. So I'm going to get the value and then network error and then file not found error.
Now, that lends itself nicely to a function that could have both errors simultaneously, because you could easily check the one you care about and maybe pass the other one up the stream, up your call stack to whoever else might care about the other one. You can kind of do that right now with Go with multi-error, errors.join, but it's kind of smuggled through this single error interface. So it's a more explicit way to do error handling. And then each error type could be its own type that has nothing to do with error. It could be a struct, it could be a string, it could be an integer, it could be whatever you want, right? So the idea is to promote errors from this barely better than any to strict types that you want. And then you return one placeholder for every possible error value your function can return. I'm not convinced that's the right answer. Yeah, go.
You're saying you're describing it, and what I'm hearing is checked exceptions Java style, where every function has to declare all the possible exceptions it can throw, except you're not only doing it in the signature, you're forcing every caller. Can you imagine a useful function that you want to call all the time, having to define all of its possible error types, and then you have to get value, comma, underscore, 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 for like ignoring all these error types that you don't care about, but you care about the 17th error type. I will say another thing. Making errors more type compliant doesn't mean your software will be better, because if what you want to do is you want to handle specific errors in a specific way, I think there are better ways to do it. Maybe not super type compliant, safe ways that, are fully verifiable by the compiler, but just pragmatic ways that are okay. Like if you really, really care about handling errors correctly, add an error code to every error and create a file called errors.go and just put them all there. Or create error types in errors.go and put them all there because it's specific to your program. But trying to do this sort of structure that will not work with any library you're using. So why try to do it anyway?
It's not idiomatic Go, so it wouldn't work with existing libraries. But let me play the devil's advocate here a little bit. How do you feel about context values?
You mean putting stuff in context, you're just using it as a bag of values?
Right.
Pragmatically, I'll put things like the trace ID there.
Sure.
But not everything that's like everything that's non-critical as far as I'm concerned, and cancellation signals go into context. And everything else is explicit variables. That's so, how I'm thinking about it.
Isn't context values the exact same thing going the other direction?
So I don't think so, because context values you choose how to use. If you don't want to, like, if a library tells you put this and that into context if you want me to behave a certain way, you can do that at the library boundary, but in your code, you can use them however you want. If you want to use them as a bag of values, do whatever.
Isn't that the same for errors, though? I mean, doesn't the library tell you here are the types of errors I might return?
So no, because most libraries don't do that. They're like, I'm returning an error, and the error string is going to contain what happened. If you really care about the handling the errors specifically, which is, by the way, a relatively rare case. Most of the time when you get an unexpected error, you either log it and move on because it wasn't critical, or you crash your software. To me, it's relatively, or you retry, you know what I mean, on every error.
I do error handling all the time in my code. So I don't know. It's not my experience.
I do error handling as well. But what I'm saying is it's very rare for me to, based on the type of the error, I look into some specific number or error message and change my behavior wildly. You know what I mean?
I do that all the time. So yeah, my experience.
I'll be surprised if most errors you handle, you actually handle. I'm not saying you don't do that a lot. I'm just saying for most errors, it's not the case. But putting that aside, what you're asking is, isn't it equivalent to pass random values in the context to getting random errors that are string? Both are kind of loosey-goosey. I agree. You shouldn't normally put a ton of values in context. And normally a function shouldn't return a million different types of errors that are extremely unparsable. And if it is a highly complicated, sensitive operation that can return multiple errors, then just the normal error interface is not good enough. And it maybe needs to return multi-error or something like that. There are exceptions where just the normal error interface is not enough, but all these cases, I think you can just wrap it with something that a list of some things like, my app's errors interface or my library's errors interface that extend error, that implement error.
You can do that, but I think that's kind of the equivalent of having a sort of, application level helper that takes a context and extracts values from it, isn't it? You're working, in other words, I feel like that's working around the lack of type safety in a way that, at least in theory,
it's extending, it's wrapping the very simplistic type safety. Working around seems like I'm saying this is not good and I'm finding a different solution. What I'm saying is this is very simplistic. Sometimes I need a more complicated tool or a more powerful tool, I should say.
All right.
And re-implementing it is kind of annoying, but I don't re-implement it the same way every time. Like when I deal with HTTP or Postgres, I'm looking at codes, and then I have a helper that's like, if the problem in Postgres or HTTP, if it was HTTP 500, or if the Postgres code was transaction failed, then I'll send it off to a retry handler. And if I'm working with a different library where the errors, are maybe they don't have codes because they decided to put it all as strings, or, they just work differently, or they send multiple errors and I need to look at error handling is different for every case. So I don't think any way you would generalize errors would help. Like the way you're suggesting is sending a type with all possible error types. How would I even define that type?
Well, it would be individual types. Is the proposal made in the podcast? Now, I want to point out, I'm not convinced that their proposal is a good one.
You're devil's advocating.
Yeah, it does bring up an interesting contradiction, at least in my own thinking, which was I've been a strong advocate for no context values except in extreme cases. Certainly, I wouldn't want to pass a database handle as a context value or something like that, right? But we kind of do that for errors all the time, and I'd never really thought about it before. So I think they bring up an interesting point. As far as context values, I definitely prefer explicit function arguments. So why shouldn't I also prefer explicit function return values? And I think the same argument applies that if I get to the point where I have too many function arguments, that's a smell. Maybe if I have too many error return values, that's also a smell. I don't know how that plays out in the real world, though, because I'm thinking about things like context cancellation. Does every function that has a context argument need a special context cancellation return value as well? Because that seems pretty cumbersome. But maybe that's the solution. I don't know. I don't know what the solution is.
I think it's just to spin your own words against you. It depends.
Yeah.
But I think in most cases, people would be happy to give up a little bit of type safety to get a lot of ergonomics and speed of development, especially if you can work in the cases where you actually care about it. Like if I came into a company that was writing Go and they were like, our standard is and we wrote a specific linter for it. Every function must define all of its possible error types in the return value. And every time you call the function, you have to address all these values. And some functions have 17 different errors, right? They talk to the network and then they write some file and then they do something else, right? Like a main of a CLI could do a million different things. But at the end of the day, you only care if it's 0 or 1, if it failed or if it succeeded, and then you can continue on in your shell script, or it failed. I don't want to I wouldn't want to work in such a code base. But, on the other hand, there were places where I've told people, hey, the error handling here is really lackluster and you got to look at all the cases, and because this is a critical part of the code, whatever. So you mentioned passing databases connections in context, setting up a DB connection correctly. It's a great example of a place where I want perfect error handling. You got to take care of all the cases and retry and whatever because the app depends on it, blah, blah, blah. So I think, again, the answer is it depends, which is not great, but I'm not sure the answer is always add all the error types to your multiple return values. I will say this is not a pattern. It's not a pattern that I thought about. And I can imagine it being useful, for a function where I deeply care about the different error types, one of them is okay and one of them is breaking or something like that. Having a value, you call the function and then in return you get the result. Non-critical errors and critical errors would be cool. I will say that normally in my code, I just have a logger for all this stuff. Again, because if there was an error and I don't care about it, I just want to log it and move on. I'll just log it and read it after. That's what I do with non-critical errors. So why even return it from the function? It is a side effect. It's not perfect functional code, whatever. But realistically, were I to bubble this error up all the way across the stack, what would I do with it? I would just write it somewhere so I can take a look at it after and try to eliminate it at the source. Pragmatically, I don't know. I don't love this idea. It is interesting.
So when I first heard the idea explained to me on our channel, I was like, that's disgusting. I can't believe anybody would suggest that. After listening to the justification, I still don't like the solution, but I have a stronger respect for the problem, and I will look at errors differently from now on. Maybe a better solution will present itself to somebody. I sort of doubt, though, that they'll be deprecating the error interface in Go.
Oh, no, this is definitely a company specific, the people on fall through might be like, okay, in my company, I added a linter that you can't use error normally, and you have to import something from errors.go or whatever. So if Chris and Matt want to come on the show and argue about it some more, of course, you're very, very welcome. We love doing crossovers. Even though we know, because we talked about it on the show, that we're not going to make any more changes to the error. That was a decision that was made, right? Stop talking about errors.
Yeah.
Well, that makes the show, I think. Let's jump to a quick ad break.
Let's do it.
Thanks for listening to our show. As Jonathan mentioned at the top of the show is supported by you. That means that we have a Patreon where you can financially support us, which is nice because this is a hobby, but an expensive one. We pay for hosting, editing fees, etc., etc. If you want to find the link to the Patreon or our swag store or past episodes or all other things Cup of Go, you can go to cupago.dev. That is cupago.dev. Other ways to support the show, including leaving a review on Spotify, Apple Podcasts, or wherever you listen to your podcasts. To now, other than reviews, official reviews, also just writing content about the show, like a blog post or whatever, helps a lot because it goes into AI training. And I think more and more people are finding us through like searching on ChatGPT or Claude. What are some Go podcasts to listen to, or what's some Go educational content? So that's a good way as well. But probably the best way support the show non-financially is to tell other people about it. We don't pay for advertising, and I think we never will. So, whatever you can do to get the show in the ears of more listeners would be really, really cool. And someone mentioned last week that they're listening to this while working out. So if you're in the gym right now, push, you can get another set in. Get another set in. Yeah, you rock. Good stuff. Other than this, I also wanted to mention that I have a Go meetup coming up that I'm arranging in SF. If you're in San Francisco, come to my Go meetup. It's next week. Jonathan, you had 2 items you wanted to mention.
I have a couple things. Yeah, I'm working on a new podcast, and I'm looking for guests. Podcast about coding with AI. I'm wondering if Shai might be willing to come on my show at some point. I have already recorded 2 episodes.
What's it called?
I don't know yet. I don't know. I have an editor lined up. Our well-known editor of this show is going to do it for me. I have a couple other guests lined up, but yeah, I don't know what it's called yet. But I'm trying to learn about coding with AI, kind of in public, because I've kind of been a late adopter of this thing. So if you have some expertise to share, reach out to me. I'd love to have you on as a guest. The other thing I want to share is I have a course coming out.
And I assume, before you jump into it, I assume Cup of Go channel is also a good place to suggest new names for your show.
Sure. Sure. The last thing I want to mention is I have a new course coming out on boot.dev.
That's awesome.
It is in beta testing. It should go public in about a week, into the month, the 30th, I believe, the official launch. It's about logging and observability in Go. Ooh. And we have a special offer for listeners of the show. If you use Cup-O-Go at checkout, you can save 25% off your first payment. It could be a monthly payment if you just want to dip your toes in the water, or 25% off the first full year if you want to pay for a year. Use promotion code Cup-O-Go and save 25% on your boot.dev subscription. That's for my course or any other course on the platform. So I'll have a link to that in the show notes. My course is Learn Logging and Observability in Go.
I don't know how good your course is going to be. I honestly assume it's pretty good because you've been teaching me Go every week, and I've kept up on it. Even though, as you mentioned, at every chance you get, I don't write a ton of Go in production.
Yeah.
But I can definitely tell you, not because Lane was on the show and as a friend of the show, but as a user, that the Learn SQL course is really good. I mean, when my wife was looking for a job, she took the Learn SQL course just to brush up on SQL before interviews. And her feedback was, oh my God, they taught me exactly what I needed for the interview. It's really well done. It's engaging. I've looked at it. It looks really, really cool. So I'm excited that you're getting a course there as well.
Yeah, I'm excited too. Yep, I hope it'll be well received.
What's that promo code again? One more time?
Cup-O-Go. No kebab case for this time. It's just.
I don't know. I don't know why they do it at podcasts, right?
know.
They'll say the promo code 17 times in every.
Call that number on your screen right now.
All right, cool, man. All right. So with that, great news about your new boot.dev course. My meetup next week. We're all very busy. We may have some exciting travel planned for the summer. There's a lot of things going on in Cup of Go land. Actually, we'll send you off. Program exited.
Program exited. Goodbye.